Hello. Yes. Okay, sir. Tell me. Yes, sir. Okay, sir. Okay. Okay, sir. Is my screen is visible to all? Okay. So right. We are moving into third unit. What is our third unit in MPNC? Interfacing. Okay. Till now, in first and second units, what we have discussed, please give response. Just will recall first and second units. What we have discussed in first and second units. Nothing.
Architecture of
Yes,
8085.
architecture of 8085. Next.
Generation of
Hmm?
computers.
What?
Language
Classification of
programming, sir.
computers.
Very good. Assembly language programming, right? Next. So we have discussed everything about 8085, right? The architecture and addressing modes, instruction set, and how we write the assembly language programming with the help of the 8085, right? Everything we have discussed in first and second units. Now we want to take the applications of 8085. Means alone using 8085 microprocessor, we can do so many things. But if we connect this 8085 with the other systems, okay, other devices, we can take so many applications, right? For example, if I want to display one LED, LED means what? Light emitting diode, right? So if I want to connect a small LED to the 8085, how we can connect? We need to connect from the outside, right? So 8085 microprocessor means what basically? Microprocessor means what basically? Definition. What is the definition? Actually, what is microprocessor? Hmm? What is microprocessor?
CPU on a single chip.
CPU on a single chip, right? CPU on a single chip means the what? Like a brain. Okay. Now, in order to perform any function, we need to give the some input, right? Or without giving input, without taking output, this processor will performs everything. Tell me, nothing. So with single CPU, we cannot do anything until unless we need to connect an interface, memory, okay, and a output. So all these are the different parts. Okay, different devices. CPU is a one device, input is a one, output is a one device, memory is also one device. Now, in order to utilize this CPU, in order to utilize the microprocessor, what we are doing? We are connecting input to the 8085 microprocessor. So through the input, what we are doing? We are giving the some functions, right? We are giving the some functions. So after giving the functions, that functions will be performed in the CPU, right? Operations, like some operations we are giving with the help of the input. And all those operations are performed in the processor. And after performing, we want to see the output, right? Now we are connecting output also. Okay. In order to see the output, what we are doing? We are connecting the output devices to the processor, right? Now, if we want to save this program, okay, save these input and output, okay, then what we are doing? We are connecting memory, okay, we are connecting memory. Now, this is a what? A complete system. This is called what? A complete system, right? Now, so here what we are doing? So in this picture, by using these arrows, we are connecting input output devices and memory also. Okay. So all these we are connecting using what in this diagram? Arrows. So these arrows is nothing but a what? Interfacing means what? Process of connecting the peripherals. Peripherals means what? Already I said input output devices which are externally we are connecting, right? So here for this our processor 8085 input output memory we are connecting externally, right? So all these are called as the what? Peripherals. So whenever we are connecting a peripherals to the 8085 means the process of connecting what is called interfacing. Interfacing means the what? The process of connecting external devices to the microprocessor to take the or to utilize our microprocessor effectively. Okay. So here in this diagram, I have given the examples of input, output, and memory. Okay. I have drawn input, output, memory. So other than this input, output, memory, we can connect other devices also, like LED, one keyboard. Okay. Any application, anything we can connect. So interfacing means what? Interfacing means what? Am I audible to all? Give response.
Yes, ma'am.
Hmm. So interfacing means what? Interfacing means what? Process of connecting external devices to the processor, right? Process of what we are doing? Process of connecting. How we are connecting? Okay, how we are connecting. So in our we cannot connect directly input to the 8085, output to the 8085, memory to the 8085, right? Like a switch, like a wire. Using wire we are connecting. Not like that. We cannot connect. In order to connect this input output memory, we need to design the circuit. Okay, we need to design the circuit. We need to write the program, right? For example, a computer is there, right? Computer is having how many parts? System, monitor, keyboard, mouse. So how we are connecting? Simply using the wires, right? Simply using the wires. So after connecting all these things, are we able to do process? Are we able to type anything without installing the drivers? New system we have purchased, right? New computer we have purchased. And this new computer, what we are doing? We are assembled everything. Okay? We are what we have assembled? Everything we have assembled like CPU, keyboard, mouse, hmm, monitor, everything we have assembled together with the help of the wires. So that indicates the what? We have connected. That indicates the what? We have connected the computer. Now our computer is ready. Are we able to operate this computer without installing the drivers? Tell me.
No, ma'am.
No. Yes. So this is what we are connecting everything. Keyboard we have connected, mouse we have connected, everything we have connected, speakers we have connected, printer is also there. That is also an external device. That one also we have connected. But until unless without installing drivers, we cannot use those devices, right? So that installation process, the drivers is nothing but a what? Interfacing programs. Okay, right? Now understand interfacing means the what? The process of connecting external devices. Here 8085 microprocessor is what? Our processor. Okay. So in order to operate, in order to utilize efficiently this 8085, what we are doing? We are connecting input, output, memory. So normally how we will connect the wires like that? We cannot connect. Okay. So after connecting this, we need to design one circuit. Okay, we need to design one circuit. And based on that circuit, we need to write some program. Are you following? Okay. We need to write some program. Drivers means what? Those drivers includes what? Some programs only. The programs which are related to the specifically that particular system, that device. We are connecting printers. Means we need to install the printer software, printer drivers. Drivers means what? Software only. Okay, in order to work that printer, we need to run the some program, run the some system. Okay, right? So that is nothing but a what? Interfacing. Now here in this unit, we are discussing, okay, we are studying about interfacing. Okay, first we will interface memory, means how to connect the memory to the processor. Okay, next IO devices, input and output devices, how to interface the input and output devices. And after then some applications, some extra devices we are connecting. So that includes the what? Third unit, right? So third unit is what? Completely about the interfacing of 8085. Completely about the interfacing of 8085. Now understand what is an interface? What is an interface? Interface is a process of connecting external devices. Okay, process of connecting external devices to the 8085. Okay, that process includes the what? We need to design the some circuit and we need to write the some program also. Then only we can interface those devices with the processor and we can use the processor efficiently. Understand? Interfacing means now we are going to discuss about memory and IO interfacing. Means we need to connect the memory to the 8085. What is the process to connect the memory to the 8085? And we need to connect the IO devices. I means input, O means output, right? So how we are connecting these two devices to the 8085, right? And how we are designing the circuits while connecting the memory to the processor or input output devices to the processor. What are those circuits and what logical circuits are involved in those circuits? Okay, everything we will study in this third unit. Understand? This is very, very important. Okay, so interface is what? Please, all of you take down. What is an interface? Take screenshot of this. An interface is a concept that refers to a point of interaction between components and it's applicable at the level of both hardware and software. Okay, components of interconnection. Okay, interconnection between the components, right? So here device we can call these are input output memory, we can call it as a device or some components also. So interface means the what? Interaction between components and the 8085, both hardware and software. Hardware means the what? We will design the some circuit. Okay, that is the hardware. Software means what? In order to work that circuit, we are writing the some program. Okay, we are writing the some program and we need to execute that program. Okay, so that's why this is called as what? Both hardware and software, and it is applicable at the level of both hardware and software, right? So this is the what? Memory and IO interface. Now, this is the a simple block diagram of interfacing. Now we are discussing about the memory interfacing, right? Memory interfacing. Keep writing as what? Memory interfacing. Draw this diagram. So here 8085 is the what? This 8085 is our microprocessor, right? Now this is the what? Memory. Memory to be interfaced to the 8085. Okay. Memory to be interfaced to the 8085. Now in order to interface this memory to the 8085, what pins we need to connect? Okay. Processor means a what? It is an IC, right? Processor means a what? It is an IC. IC is consisting of what? Number of pins. How many pins this 8085 is consisting? 8085 is having how many pins? Is my voice is audible, all of you? This is a simple question I asked.
40 pins.
40 pins. Okay. So 8085 means a what? An IC. A simple IC which consisting of 40 pins. Now, among these 40 pins, now what we are doing? What is our aim? We need to interface memory to the 8085 processor, right? Now, in order to interface memory to the 8085, how many pins among these 40 pins we need to connect? Okay, Is 40 pins we need to connect to the processor memory? No. We need to connect only 3 pins. Okay. We need to connect only 3 pins. What are those 3? The first one is address lines. Okay. First one is what? Address lines. Means address pins. All the address pins. How many address pins 8085 is having? How many address lines? 8085 is having how many address lines? 8085 is having how many address lines? 16
16.
address lines and 8 data lines, right? 8 data lines. And among these 16 address lines, 8 address lines are first starting, lower address lines are multiplexed. Okay, demultiplexed with the data lines. And another address lines are singular, right? Normal address lines. So, in order to interface this memory with the 8085, first we need to connect all the address lines. Okay, all the address lines like A0 to A15. Okay, how many address lines we need to connect to the memory? All the address lines A0 to A15. So here among this A0 to A15, A0 to A7 are A0 to A7 are demultiplexed with what lines? Recall the pin diagram. Pin diagram of 8085. A0, A7 address lines are multiplexed with the D0 to D7. Okay. AD0, AD7. Now remaining A8 to A15 address lines directly we need to connect. So how many lines we need to connect in order to interface the memory to the 8085? A0 to A15 address lines and then D0 to D7 address lines. Means total 16 address lines we need to connect and 8 data lines we need to connect. Okay, 2 are over. Now what are those? What are these control lines? Control lines means what? Hmm? Read and write. Okay, read and write signals. Control signals means what? Control lines means what? Read and write. Read and write also there, right in the pin diagram. So all these pins we need to connect to the memory. Okay, this is a simple block diagram of interfacing memory to the 8085. Understand? So in order to interface the memory to the 8085, what we are doing? How many pins we are connecting? How many pins we are connecting? A0 to A15 address lines, total 16 address lines we are connecting. And next, 8 data lines we are connecting directly from 8085 to memory. And then next, control lines. Okay, control signals. What are those control signals? Read and write. Okay, read and write signals also, read and write pins also. We need to connect from 8085 to memory. Understand? Understand the block diagram of a interfacing of memory to the 8085, right? Now, next. So this is interfacing pin. See, higher order address bus A15 to A8, lower address data bus AD0 to AD0, 7 to AD0. Next, control lines. Okay, control signals I said here. What pins we are connect? We need to connect address lines, data lines, and control lines. So here control lines or control signals means the what? Read, write. Okay, read, write. IO by M bar. IO by M bar means the what? IO stands for what? Input output. M stands for memory. ALE is used to enable the address lines, and ready is used for the ready shows the what? Our processor is ready for operating anything. Okay. These are the what? 1, 2, 3, 4, 5. 5 are the control signals. Now, in order to interface anything, whatever it may be, that may be the memory or that may be the IO device or anything, any external device. These pins we need to connect directly from the 8085 to any other device. Understand? All the address lines, that is A0 to A15, and all the data lines D0 to D7, and next these 5 control signals or control pins, right? RD stands, ALE stands for what? Address latch enable. Address latch enable means what? Whenever this address latch enable is goes to high, we can address, we can give, we can allot the address for the certain data. Okay, data is given through the with the help of the input, right? That data we need to store in the memory, right? In order to store the data in the memory, we need to allocate the some address, right? So when we need to allocate, when we are allocating the address, whenever this ALE pin goes to 1, logic 1, okay, then only we can allocate the address in the first cycle. Okay, and next IO by M bar. IO by M bar means the what? I stands for input output, O stands for output, M stands for memory. Now, what we are interfacing here? Huh? What device we are interfacing? Memory. So, whenever we need to interface the memory to the 8085, this IO by M bar should be 0. Okay. Whenever this IO by M bar is equal to 0, then we can interface memory to the 8085. Means we can store anything in the memory. We can operate the memory. If we want to interface IO devices, input output devices, then this should be equal to how much? 1.
1.
Bar stands for 0. This should be enabled for 0. Here there is no bar on the IO device. Means this pin will be enabled for 1. Whenever this is equal to 1, what will be enabled? IO or M. IO will be enabled. If this is equal to 0, memory will be enabled. This is called what? Multiplexed pins. Okay. One pin is used for two operations, right? One pin is used for two operations. Here ALE is only one pin. Here no operation, no two operations, multi operations. But here two operations. Okay. If we want to interface the memory to the 8085, this pin should be goes to logic 0, right? If we want to interface IO, then this pin should be goes to logic 1. Understand? Now, next read. Read means what? Read means what? Whenever processor is taking something, okay? Processor is taking something. Something we have stored in the memory, right? Now processor wants that data, okay? Some data we have stored in the memory. Now processor wants the data from the memory. Then what we can say? Processor is reading, okay? Processor is reading, right? Now processor wants to store some data in the memory. Then what we can say? Processor is writing some data into the memory. Okay. So in order to take the data and in order to give the data, what signals we want? Read and write. Read means what? Processor is taking. Okay. Processor is taking. Writing means the what? Processor is giving. Okay. Reading means fetching the data. Writing means storing the data. Okay. Ready indicates the what? Our processor is ready for any operation. Okay. Our processor is ready for any operations. So these are the interfacing pins we need to connect before interfacing any device to the processor. Understand? Understand? Give some response
Yes,
so
ma'am.
that I can move to the next slide. Okay. This is the basic diagram of interfacing any device to the 8085. So here I have taken example as memory. Okay. So I am interfacing memory to the 8085. Now, what lines, what pins I need to interface whenever we want to interface any device to the 8085 means these are the pins. Okay. These are the pins to interface any device to the 8085. Okay. Now this is about the address bus. Okay. Address lines. So how many pins we need to interface? A0 to A15 address lines. So this is about this. Okay. So total how many address lines we are having? A0 to A15, 16 address lines. So among these 16 address lines, we are dividing into a two blocks, right? One is higher order address, lower order address. Higher order address means what? A8 to A15 are called as higher order address. Lower order address means A0 to A7. Okay. First 8 address lines are called lower order address lines. Okay. And next 8 address lines are called as higher order address lines. Now lower order address lines are demultiplexed with the what? Data lines. 8085 is having 8 data lines. Okay. 8 data lines. So 8 data lines are multiplexed with the these address lines. Okay. Now demultiplexing means what? Okay, I said 8 data lines are multiplexed with the 8 data lines are multiplexed with the 8 lower order address lines. That is A0 to A8. Now demultiplexing means what? Separating the D from AD. Okay. Separating the D from AD or A from AD. Right. So these are multiplexed, right? AD is there. Okay. AD is there and both are having no bar. Means both will be enabled for logic 1. Yes or no in the pin diagram? If there is a bar, for example, this here. You consider this IO by M bar. This is also a one pin, but this pin is having two functions. Okay, whenever for logic 0, M will be enabled, and for logic 1, IO will be enabled. But whereas here AD0 to AD7, no bar is given. Means both will be enabled for logic 1 only. Okay, both will be enabled for logic 1. Now, how at what time which pin will be enabled, when A will be enabled and when D will be enabled? How we can say? Understand? Are you following me? Are you following me? IO by M bar means what? That is also a one pin. This is also a one pin, right? So here that pin IO by M bar means two functions. Okay. IO is the one function, M is the one function. But there we have mentioned bar on the M. Okay. We have mentioned bar on the M. That indicates what? Whenever that pin goes to logic 0. Okay. Whenever that pin goes to logic 0, then memory will be functioned. Okay. Means processor can do anything with the memory. Processor can read the information, processor can write the information into the memory. Right? Now, whenever that pin is goes to logic 1, then IO will be activated. Okay? IO will be enabled. Okay? So that is easy. How we are saying how that is easy? Because when that pin is 0, memory will be enabled. When that pin is goes to 1, IO will be enabled. But here AD is there. Here no bar. No bar on the D. Is there any bar on the D? Or is there any bar on the A? No. Here also two functions. Okay. Here also two functions. Right. Now, how when these two functions will be enabled for logic 1 only. Why? There is no bar above these pins. Okay, means these pins will be enabled for logic 1. Both will be enabled for the logic 1. Right? Then when A will be enabled, when D will be enabled, tell me. Hmm? So these are enabled with the help of the timing diagram. Okay. Are you remember timing diagram means what? Every pin or every instruction, for every instruction, the certain time will be allocated by the processor. Okay. And that time, that may be a 1 millisecond, some few milliseconds or microseconds. That seconds will be divided into equally 4 parts. Okay. that seconds, that time is divided into equally four parts. Okay, T1, T2, T3, T4. Now, always A will be enabled during T1 period. Okay, always A will be enabled. Means from this demultiplexing AD, A will be enabled during T1 and remaining three cycles T2, T3, T4, D will be enabled. Means data will be transferred from processor to memory or memory to processor. Understand? Understand? This is what? AD7, AD0 to AD7. So in this way, these pins will be operated. But here we need to demultiplex. Okay, we need to demultiplex these AD. Okay, from these AD, we need to demultiplex D or A. So how we can demultiplex? By using one device. Okay, by using one device called latch. What we can call latch. So latch is used for what? To separate address lines from the AD multiplexing line. Understand? Understand? Tell me, is my voice is audible?
Yes, ma'am.
Understand? What is latch?
Yes.
What is latch? 18. Rule number 18. Rule number 18. I'll keep you as absent.
Yes, ma'am.
చెప్పమ్మా వాట్ ఈజ్ ల్యాచ్ నీకేం అర్థమైందో అది చెప్పు ల్యాచ్ ల్యాచ్ అంటే ఏంటి వాట్ ఈజ్ ల్యాచ్ డయాగ్రామ్ చూడండి సో హియర్ ఇన్ దిస్ డయాగ్రామ్ ఏడి లైన్స్ ఆర్ వాట్ కాల్డ్ multiplexing lines, right? Now in order to separate A from AD lines, we are using one device, right? So that device is called as what? Latch. Okay. Rule number one. Rule number one.
Yes, ma'am. Yes, ma'am.
Now you tell me what is latch? Latch is what? Tell me.
It is a circuit
It is a device.
which stores
Separates. AD are combined, right? A is different,
Yes,
D
ma'am.
is different, but AD are combined. So now in order to separate these AD lines, what we are doing? We need to connect one device. Okay. So that device
Yes,
will
ma'am.
separate these AD lines. Right. So that device is called as what? Latch. Okay.
Latch.
Rule number 2. What is interfacing?
Process of connecting external devices to the memory
Not
processor.
memory, processor.
Processor.
Okay. Here, processor. We are discussing, we are studying about the processor. Now, in order to connect the anything, whatever it may be, that may be a memory or input output devices or any external device, if we want to connect it to the processor, then that process is called as what? Interfacing. Okay. So this interfacing includes the what? Hardware. Hardware means the what? First, we need to connect with the help of the wires. Right? Keyboard is there, mouse is there. Okay. CPU is there. CPU is the processor. Monitor is also there. Okay. We are not connecting anything through hardware. Just we are installing the drivers. We can able to work with those keyboard and mouse, monitor. Tell me, no. Means what? In order to interface anything, any device to the processor, we need to connect hardware device and as well as we need to install the software program also, right? Hardware and as well as the software. We need to Take the help of hardware and software. A simple example of hardware is what? Wires. Okay. How we are connecting monitor to the processor, how we are connecting keyboard to the processor, mouse to the processor, printer to the processor through cables. Yes or no? Through cables we
Yes,
are
ma'am.
connecting, right? Through cables we are connecting. Now, after connecting through cables, until unless installing the drivers, we cannot utilize them. First, we need to install the drivers. ఈ రెండిట్లో ఏ ఒక్కటి లేకపోయినా we cannot interface, right? So interface means the what? Process of connecting any devices to the processor, okay, to the microprocessor, which includes what? Both hardware and as well as the software. Hardware means the what? Some circuit. Okay. Software means the what? In order to work that circuit, we need to develop, we need to design, we need to write some program. Right? That is the what? Software. This is called as interfacing. Understand? This is called as what? Interfacing. Understand? And what are the pins we need to connect before going to interface to the processor? What are the pins we need to connect? Rule number 14. Rule number 14. Are you there?
Yes, ma'am.
Ah. What are the pins we need to connect? A pins we what are the pins we need to connect? A pins connect చేయాలి if we want to interface any system, any device to the processor. Hmm? What pins we need to connect? I have given the diagram also. Hmm? What pins we need to connect? Tell me, Rohit, what pins we need to connect? 14, 16, 16, 16.
Yes, ma'am.
What pins we need to connect? Unmute yourself and tell me. What pins we need to connect? See, here are given pins. All the address pins we need to connect and all the data pins we need to connect and control pins. Control pins includes ALE, IO by M bar, read bar, write bar and ready. Understand? Understand? Okay. Today, please all of you mute yourself.